the lesson. In the earlier lesson, we were just introduced to the plane and the major parts of the plane. It's time for us to move forward and learn a little bit more. In this lesson, we will learn about the flight controls in a little bit of depth. Talking about flight controls, it's an in-depth subject. The reason being there are several types of planes. There are very simple training planes to big, huge jets flying long distances, etc. So there are different types and different types of flight controls. In any case, in an aircraft, flight controls are a major component. So it's good to develop a good understanding about flight controls. In this lesson, we will be talking about controls that are applicable to medium kind of medium range jets, and which is also applicable to long range jets, and of course it will give a overall good understanding of flight controls. Let's move on. You will find this lesson interesting. In the last class, we were introduced to this the tail plane and the horizontal and the vertical stabilizer. In this lesson, we will dwell more on the details of the tail plane, the horizontal stabilizer, and the vertical stabilizer. Firstly, the elevator. Elevator is a very important flight control. As we have already seen, the elevator moves in an up-down direction, and it controls the flight path of the aircraft in the vertical plane. That is, the aircraft climb, maintaining a straight and level flight, and descending. All these movements are controlled by the elevator, and it undergoes severe extremes of loads, and it's a very important flight control surface, which we will learn in more detail. The last lesson, we were introduced to the control column, which the pilot operates all the control surfaces from the cockpit. So let us learn more detail. The pilot operates the control column in the fore and aft axis, and up-down motion, that is, which controls the elevator movement. When the pilot pulls the control column backwards, the elevator moves upwards in an angular motion. This leads the aircraft nose to pitch up or tending to go up, resulting in aircraft gaining height. Similarly, when the pilot moves the control column forwards of the neutral position, the elevator moves in a downward and angular motion. Then the aircraft nose tends to pitch down, and the aircraft starts losing height. And if you have to maintain a steady height, then the elevator has to be kept in a steady state of action with very, very minor changes, which we will see in future lessons. Here I tried to show the working of the elevator, the movement of the elevator in a graphical form for your better understanding. The next control surface which we are going to see is the rudder. The rudder controls the yaw of the nose of the aircraft, and it is controlled by it is operated by the rudder pedals, which will be operated by the pilot by his foot in the cockpit. So the rudder pedals are operated in a to and fro motion, up and down, fore and aft axis, and when the pilot applies the left rudder pedal, the rudder moves to the left and aircraft tends to yaw to the left direction. Similarly, when the rudder pedal direction reverses, and if he operates the right pedal forward, obviously the left pedal will come back by then. When the right pedal is pressed forward, then the rudder moves to the right and the aircraft will tend to yaw to the right. So this is again a very important control surface which provides great directional control for the aircraft. Here I tried to show the working of the rudder and the movement of the rudder in a graphical form for your better understanding. Here I put a picture of a rudder control of a Thai Airways jet for your understanding. The next control which we are going to talk about is the aileron. We already been introduced to this aileron in our previous lesson. There are two ailerons fixed on the outer edge on either side of the main wings, and they control the rolling moment of the aircraft. And it is operated by the control column by its clockwise, anti-clockwise, to and fro motion, and the ailerons control the rolling motion. In this picture, we can see the aileron control of a large jet aircraft. In many smaller planes, this aileron will be a single piece and controlled by the control column. But in this case, you can see that it is in two different pieces, which is called the split aileron. It has got some advantages which is beyond the purview of this lesson. But suffice to understand that ailerons are of different kinds, and so this is the one the picture has been shown is a split aileron of a large jet aircraft. Here I tried to show the movement and control as controlled by the control column of the aileron in the rotary motion and the motion of the aileron per se to give you a better understanding. So far we saw three control surfaces, that is the aileron, the elevator and the rudder. constitute the primary control surface of the plane, and they are called so, primary control surfaces. Now, there are other control surfaces which perform different functions, which we shall be seeing. The first one I want to introduce you to is the movable horizontal stabilizer. In most modern aircraft, this horizontal stabilizer is a movable stabilizer. It is operated electrically from the control column by pressing a switch. It goes in the up and downward motion as shown here. What are the advantage is that when these high performance planes have change in speeds during the flight, the rearward force, which we call the drag for the flight, keeps varying and increasing. So normally they would be neutralized by the movement of the elevator, but that doesn't serve one whole purpose. The movable horizontal stabilizer will enable this reduction in this drag. This drag is called the trim drag, so which eventually leads to better fuel efficiency. The next important control surface which I want to explain is the flaps. These flaps are controls which are slushed normally under the wing. They are tabs kind of structures under the wing, and they come out protruding down and drooping downwards when operated. The flaps are usually used for the takeoff and the landing phases. What are the advantages? They improve the lifting capability of the wing so that the aircraft doesn't use one whole lot of runway length. That means it is able to lift up within the runway lengths available at that particular all-up weight. Even though the rearward force, the drag force, which we talked about earlier also, is going to increase with the lowering of flaps because of its frontal area which it's projecting. But the advantages of its lifting capability in this phase of flight for the takeoff and landing outweighs the increased drag. Of course, these are retracted immediately after takeoff, and they are lowered only before landing, and they are retracted during all other phases of the flight, so they don't present any drag. So that's about the flaps. Of course, there are several types of flaps which we are not concerned at this in this lesson. I got hold of a picture of a large jet aircraft with the flaps lowered condition for your understanding. The next control which I am going to talk about is the slats. These slats are fixed to the leading edges of the wings. They have a very similar profile and shape of a big wing, but in a very small dimension, giving it the advantages of its shape. They are operated by a single lever which operates the flaps, and they operate in conjunction with the flaps in general. What are the advantages? They provide stability, especially in the lower speed ranges of the aircraft, especially when you are during the takeoff and the landing phase, where the aircraft encounters lower speeds. These slats provide much better stability to the wing and the other control surfaces. That's the advantage of the slats. I put a photograph of an aircraft with the slats operated. In fact, you can see the slats and the flaps having been lowered. I presume the aircraft is landing, and uh, so this picture will clarify one whole lot of things for you. The next control which I am going to talk about is the speed brakes. Speed brakes are flat panels which protrude out as shown. They come out during the flight and especially during landing. The function it performs is that it disrupts the airflow over the wing. Normally, over the wing, the airflow would be very smooth and linear without any disturbance. Now, these speed brakes, when they protrude out, they create a lot of disturbance in the airflow. Thereby, they are able to increase the drag, the rearward force which we have been talking about, and they are also able to prevent lift being generated. That means the upward force on the wings being generated. So they dump quite a lot of lift and increase quite a lot of drag, which is why it's called the speed brakes. So if the aircraft were to be having any speed, it will decelerate immediately. Therefore, it is very effectively used during the landing phases of the plane. And during flight, if you are to reduce speed, it will be useful to operate the speed brakes to quickly reduce the speed. And also, by using the speed brakes differentially over both the wings, the aircraft is able to improve the turning capability. Otherwise, big performance aircraft have very large resilience to turning, and it may not be very easy to turn normally. So speed brakes aid in aircraft turning as well. I put a picture of a plane where the speed brakes have been operated, and of course the flaps also have been lowered, as you can see. And I also followed it up with a video which I took live when the speed brakes and the flaps were operated during a landing phase in one of the flights which I flew. You can see that in the following as we follow the lesson. The last control surface which I want to explain is the trim tabs. These are all small tabs attached to the primary and the secondary control surfaces, which are operated by small electrical switches in the cockpit or mechanical turn drum wheels in the cockpit. They 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 are able to reduce the control surfaces when the aircraft is in a transit position or it's in an out of trim position. What happens is when you operate the primary flight control surfaces, there is a pressure which is exerted on the control column. The pilot usually has to keep it holding for some time, which is not possible throughout the flight. Therefore, these additional forces which are generated have to be trimmed off or reduced. This is enabled by these trim tabs. The detailed working of it is well beyond the purview of this lesson, but suffice to understand that they enable smooth and reduced workload for the pilot in operating the control surface. We come to a conclusion of this lesson on control surfaces. This is a brief introduction to the control surfaces of the airplane. Of course, for a professional who is involved in flying, he will learn much more in detail. But as a starting point, this gives a fair understanding, I suppose, for any aspiring pilot and any aviation enthusiast so far. Once again, I thank you for going through the lesson patiently, and please feel free to offer your comments on the Gmail address which has been given at the end of the slide. I thank you once again.